Hello guys, today we're going to study 3.2 polynomial function and their graphs. Here we have a definition of a polynomial function. You can pause this video and then take a look. If you have a f of x equal to this whole thing, this form, then you know this is a polynomial function. The main thing you need to know is one is the degree of the polynomial function, which is the n right here. I'm going to label this n. Alright, basically that is your highest power. Also, another thing is very important that we need to know is the leading coefficient. In this case, right here, that is the leading coefficient. Okay, for example, if I have something like this, f of x equal to 3x to the fourth power minus 2x plus 4, then you need to know our leading coefficient is equal to, in this case, that is right here, alright? Then that will be 3. And then the highest power in this case, alright, that is 4, which means this polynomial is a degree of 4. So here we have the leading coefficient test for the end behavior. So if you look at this, we have two cases. If we have n equal to odd, then we're going to have two cases. All right, in this case, the first one is we're going to have falls left and the rises right. Okay, that's where this portion comes from. Then also, if you look at the second one, we have rises left and then falls right. That's where that graph comes from. There's other two cases for n is even. Of course, this graph is very long, it's difficult to remember. So here we have an easy chart. Let's go ahead and take a look at how we use this graph. So here we have example 1 using the leading coefficient test to determine the end behavior of the graph of f of x equal to x to the third power plus 3x squared minus x minus 3. So our a sub n, the leading coefficient, in this case our highest power is right here, right? The highest power is right here. And then we need to figure out what is the number from your x to the third power. So we can imagine this have 1 right there. So the leading coefficient is 1. Also we know our n is 3. That is the highest power, which is the degree of a polynomial. A sub n equal to 1, that means it's greater than 0. N equals to 3, that means n is odd. So now we're going to look at this table. How can we match this? Okay, so if you look right here, a sub n is greater than 0. So that means we have to look at the first row. Okay, so we're going to look at this row because a is greater than 0. And then we also have to look at n is odd. Now we're going to look at this as my column. Right, n is odd, so we're going to look at this portion. Wherever we overlapped, that is our end behavior, which in this case it turned into orange color. So we're going to have something like this. Right, that was the orange color. So this color right there. So that means we're going to have falls left and rises right. So then you are done. For the second part, we need to find all zeros. So in this case, all you have to do is just set this whole thing equal to 0. So in this case, we have to factoring by group. We can factor this x squared out. So what left is x plus 3. Take a negative 1 out, then you're going to have x plus 3. So we'll factor it by grouping. So right there. So now we're going to factor that part out. So we're going to have x plus 3. So whatever left over here, we're going to put x squared minus 1 equal to 0. Are we done? So in this case, we can factor a little bit more. X squared minus 1. So that's a squared minus b squared form, which means I can factor this as a plus b, a minus b. Which means we're going to have x plus 1 and x minus 1 equal to 0. So we're going to solve everything. Finally, we're going to have x equal negative 3, negative 1, and 1. So our zeros are negative 3, negative 1, and 1. Example 2, using the leading coefficient test to determine the end behavior of a graph of, now we're going to have f of x equal to negative 4, x to the third power, x minus 1 second power, and the x plus 5. So for this type of questions, we're still going to do the same. A sub n equal to, in this case, leading coefficients negative 4, so we're going to make sure this is less than 0. And then for n, the degree of the polynomial, in this case, because we have a multiplication right here, so in this case, we're just going to add all the exponents. Okay, if you don't follow, here we have a 3, and then we have 2, and then we also have right here, even though we cannot see, that actually have 1 right there, give us 6. So our n in this case is even. Alright, let's take a look at this. So a sub n is less than 0, so now we're gonna look in this. So let's look this. Okay, so we're gonna look at this row, and then we also have to look at n is even, or look at this column. Okay, we overlapping right there. That's the reason why we're gonna have false both left and right. Okay, so that's why it's so important you memorize this. Then we also have to find all the zeros. Let's go ahead and take a look. When looking for all the zeros, all we have to do is just set this whole thing to 0, then solve it. So we have to solve this, but in this case, they already factored for us, right? So we don't have to do anything pretty much. We're just going to say, okay, our x cubed equals 0, which means x equals 0. All right, so we're going to have x minus 1 equals 0. We're going to have x plus 5 equals 0. This gives us x equals 1, x equal to negative 5. Okay? Alright, what is the multiplicity? If you look, I already wrote it right here. If you have x to the third power, so that means your x actually multiplies 3 times. Because from the 0, we find that x equals 0. So because x equals 0, we say the multiplicity of 0 is 3. Okay, where that 0 come from is from right here, so make sure you know where that come from, okay? I'm just separated. And then we look at the second part, x minus 1 to the second power. Then again, we know this is just x minus 1 repeated twice. That's why we said the multiplicity is 1 is 2. Okay, so that's from right here. I just repeat it over. So all you have to think is the exponents pretty much is the multiplicity. So we're going to say for x equals negative 5, we're just going to say the multiplicity of negative 5 is what? 1, right? Because in this case, we didn't repeat anything. Right here, the exponent is 1. So let's go ahead and look what is the multiplicity related to graphs. Okay, so we say if r is a 0 of an even multiplicity, it's right here for the orange graph right here. If we have something like this, we say even touch. All right, we're talking about touch this x-axis. And then if we say there's it's an odd multiplicity, then we say it's a cross. If you look at right here, we crossed. Okay, for the even part, we actually touches, then we turn away from your x-axis. Again, for the odd, we say it's across the x-axis. That's where you can just remember even, touch, odd, cross. It's very important when we're doing the graph, okay? So for example 3, find the zeros of a polynomial functions. So we're just going to set this whole thing to 0, and then we're going to solve it. So in this case, we can take a negative x squared, that would be minus 4x, and then plus 4 equal to 0. So once we look at here, we realize, hopefully realize this is just a x minus 2 squared equal to 0. So once we have this, we're just going to have x squared equals 0, just give us x equals 0, and then x minus 2 equals 0, just x equal to 2. So which means the zeros are 0 and 2. Alright guys, so here we have the intermediate value theorem for polynomial functions. The main part I highlight right here. You can look at the graph really quick, okay? So we have plugging in point A and plugging in point B. So if the output, alright, if you look at the output, f of A and f of B, they have opposite signs, then we say there is at least one value of C between A and B for which f of C equals 0. So it's the same thing as the equation f of x equals 0 has at least one real root between A and B. Okay? So let's look at an example, and then you're going to realize this is a really easy questions. Okay, example 4, using the intermediate value theorem. Show that the polynomial function f of x equal to x third power minus 2x minus 5 has a real 0 between 2 and 3. So all you have to do is you just have to plug in these numbers. We have f of 2, right? So we plug in two numbers. One is 2, one is 3. We're going to plug in those. And then you just evaluate it. All right, so that will be 2 to the third power minus 2 times 2 and minus 5. So every x I see, and then I will plug in from 2. then this whole thing will give me -1. So we'll do the same. We're going to plug in 3 as well. And then you compare them. You realize this is negative, this is a positive. That is the opposite sign. By the intermediate value theorem, f of x has a real 0 between 2 and 3. So what if you're going to have, let's say, this is going to have +1 and +16. Then this wouldn't work. This is the easiest question. Should be a bonus question. Don't get it wrong, okay? Alright, let's move on. So example 5, we need a graph f of x equal to x to the 4th power minus 4x squared plus 1. Alright, step 1, we need to find the end behavior. So by using the leading coefficient test. So here we're going to have a sub n equal to, in this case, you remember you have a invisible 1 right there. Then this is greater than 0. We're going to have n equal to, in this case, it's 4 because it's right there. So here, that means n is even. So then we match this graph right there. So it's greater and then it's even. That means you're going to have both sides rises. Then we have a step 2. Find the x-intercept by solving f of x equals 0 and determine multiplicity of zeros, even, touch, odd, cross. Okay, so let's go ahead and look at this. So we can solve this. For this type of question, we can say let u equal to x squared. So we rewrite this, that will be u squared minus 2u plus 1 equals 0. So then we can factor this as u minus 1 squared equals 0. Or we can write it in this form. We can write it u minus 1 and u minus 1 equals 0. Once we have this, we can bring this x squared sub back. So we're going to have x squared minus 1, and then we're going to have x squared minus 1 equals 0. And then we're going to solve this whole thing. That will be x plus 1, x minus 1. The second part is x plus 1 and x minus 1 again, because we can factor this as x squared minus b squared form. So once we have this, we can simplify it here. We can rewrite this, put them together. So that will be x plus 1 to the second part, x minus 1 to the second part equals 0. Then the rest of the stuff, we can just solve it. We're going to have x equal to -1 and x equal to +1. If you could just, from here, right away, you'll be able to just factor it. Then you can skip this let u be x squared form, okay? So if you can't, you can use the letter u to replace x squared. But either way is fine, okay? So once we have this, we have to determine the multiplicity of zeros. So now we look. Okay, we got x equal to -1. The multiplicity of -1 is what? Is 2, right? The multiplicity of -1 is 2. And then we also look at the multiplicity of 1 is 2 as well. So the reason why we need to know this, because once we know this is a multiplicity is 2, that means it's even, right? So that 2 is even. We said we even touches, right? So here we also have an even. Again, this is all from here. Even touch. Remember, so we try to memorize this. So from this piece, this 2 piece of information, we can actually figure out this graph should be look like something like this. Okay? We said we have -1, that said here is -1, and then here we have another 0 that is 1 right here. From step 1 we had both sides rises. So that means something like this. This graph should look something like this. Okay, something like this. Because we don't know what's happening in the middle, by the way. So we know if it's even touches, then this is going to turn. All right, this is not going to cross. This both sides are going to be turning, and then the end behavior gives us both sides rises. Okay. Please make sure you understand the fact is you have to show work for your tests and quizzes. Okay. So when looking for y-intercept, we've done it so many times in the past. We're just going to plug in f of 0. Say f of 0. So your function was, okay, just in case you forgot the function. That was the x to the fourth power minus 2x squared and a plus 1. So all you have to do is just plug it in. It's pretty straightforward. It's just going to be 1. So that means your y-intercept is 0, 1. It's really straightforward. If you think about it, the y-intercept is 0, 1. So now we can go back here. Okay, that is 0, 1. That's another point we got right there. So let's say this is 1. Alright, step 4, we need to check if this is a y-axis symmetry or is origin symmetry. All you have to do is just plug it in, f of negative x. So for every single x you see, you plug in negative x, that would be the fourth power, minus 2 times negative x to the second power plus 1. So all we did is plug in this portion, alright, for every x we see right there. So we plug in for negative x, right? So once we have this, because negative x to the even power, so we're going to have, in this case, we're going to have x to the fourth power minus 2x squared plus 1. So that is our f of negative x. Then now I compare this to my f of x. I realize they're exactly the same. Because of f of negative x equal to f of x, so then we say this is a y-axis symmetry. So step 5. Alright, step 5 is using the turning points n minus 1, check the graph. We say if f is a polynomial function of degree n, then the graph of f has at most, alright, has at most n minus 1 turning points. So early we already pretty much graphed most of them. So we had something like this, right? Rising, alright, rise at both sides. So all you have to do is just connect the rest, okay? Because we also figure out the y-axis is a symmetry. This means, okay, this means if I fold this graph right here, looking this as your mirror, my y-axis is my mirror, then they fold together and then this can match perfectly, okay? And then remember, if we look at here, we have turning points. Because the degree, if you go back to look at the function, the degree was 4, okay? N is 4. So n minus 1 is just 3. That means the most turning points we can have, this is right here. So we turn it one time right here. We turn it another time. I turn it one more time. That is 3 turning points. At the most, this is 3 turning points. So we got this graph correctly. Okay, so that is how you graph this. Let's go back and look again. Alright, let's go ahead and graph the example 6. F of x equal to negative 2, x minus 1 and square, and then x plus 2. So I wrote down all the steps on the right side. Okay, so let's look at this. So again, we start with the a sub n in this case is negative 2. That is less than 0. And then also our n in this case, remember, here we have a product right here. That means our n is 2 plus, right here, invisible 1, which gives us 3. So once we have this, and then we realize we're just going to match here. We have a is less than 0, okay, the second row, and then n is odd. That means we're going to produce something like this. Rises left and falls on the right. So then we're going to look for the x-intercept. We said we're just going to solve this. We're going to put everything equal to 0. So we're going to have x equals 1 and x equals to negative 2. Okay, so then we realize that this is even. We said the even touches. Okay, this is the odd cross. Okay, so from until right here, you should have in your head, alright, something like this should be in your head. You should realize, okay, we're going to have a 1, okay, we'll also have negative 2. This number right here, those are my x-intercepts. So then we realize, okay, for negative 2, because the odd cross, okay, so we're going to have something like this, odd cross, because here we have the end behavior. That's why I'm draw this arrow right here. And then our 1, in this case, x equals 1 is going right there. Okay, so because x equals 1 is even touches, this is going to turn and then goes down. And then step 3, y-intercept, so that will be negative 2 times 0 minus 1 squared, and then 0 plus 2, and then that will be negative 4. So that is my y-intercept. Y-intercept is 0, negative 4. So we're going to have something like this. Okay, again, I'm just drawing this to have an idea, okay, what my graph look like. Step 4, if you look at this information, okay, so far we got this graph right here. You should realize this doesn't have any y symmetry or the origin symmetry, right? Because you can just skip it. If you want to, you can do it, but you're going to end up neither anyway. Okay, so we're going to skip it. Okay, so before we do the step 5, check the turning points. You should know our n is 3, so maximum our turning points is going to be 2. So we can finish this graph. Let's make it a little bit nicer right here. Anyway, so here is what from our information we got, right? So we know the 2 turning points, we know those x-intercept and y-intercept. The only part we don't know is what happening to from here to here. So what you can do is, in this case, because we're doing it by hand, you can actually plug in some extra points, such as we can, we try to figure out what's going on the negative 1. So you can plug in your negative 1 inside your function, then you realize you're going to end up with negative 8. So which means when you have negative 1, so you're going to have negative 8 right here. So you can plug in a couple extra points to figure this out. Okay, then you're going to ask me why you know this negative 8 is when you're going to turn. You can plug in this negative 1.5. Okay, you plug in this negative 0.5 and see what's happening there. So that is how you figure out, because this is going to give you negative 1.25, and then here you're going to get negative 6.25. That's the reason why I know this is my negative 1, negative 8 points right there. Alright, so again, the main idea is you need to find your x and y intercept, you need to know the end behavior, you need to know the symmetry, and then you're using the turning points to check your graphs. So that is the main thing you need to show work on your test. Alright guys, I know it's a lot of stuff going on here, so please do some homework examples, and then please feel free to ask me questions. Thank you for watching the video. I'll see you guys next time.